Hello children, welcome to my channel. Today's topic is Midpoint Theorem and its Converse Part 1, Class 9. Okay. In this chapter there are 3 theorems. One by one I will explain all the theorems. That will be completed in Part 1. From Part 2 I will go to examples. Okay. So the first theorem is MPT or midpoint theorem. In short we say MPT, midpoint theorem. Now what is this MPT? Okay. It states that the line segment joining the midpoints of two sides of a triangle is parallel to the third side and is half of it. Means suppose there is a triangle, any kind of triangle, okay, it may be acute angle triangle, it may be right triangle, it may be obtuse angle triangle, it may be scalar triangle, it may be isosceles triangle, okay, any type of triangle. Let us take the midpoints of AB and AC, okay. Let the midpoint of AB be M, let the midpoint of AC be N, means AM is equal to BM and AN is equal to CM. Now according to this theorem, if we join MN, this MN will be parallel to BC and will be half of its length. Means if this is 6 cm, this will be 3 cm, or if this is 10 cm, this will be 5 cm. That is the relation. Okay. So let us prove this theorem. Given M and N are midpoints of AB and AC given, okay, M and N are midpoints of AB and AC. To prove MN parallel to BC and MN is equal to half BC. Okay, this we are going to prove. Now let us go to proof. For this proof we need construction. Okay. Draw CP parallel to BM to meet MN produced at P. Try to understand this. Draw CP parallel to BM. Okay, that means from through C you have to draw a line parallel to BM or BA. Same thing. BM, BA, same. Parallel to BA in order to meet this Mn produced at P. So let us produce this Mn. Okay, in this way. Then through C or from C we will draw a line parallel to BM. Like this. Okay. This point is P. Now this is parallel to this. CP parallel to BM. This Mn has been produced and they are intersecting each other or meeting each other at P. Next. We can easily prove congruency between these two triangles. Okay. These two. I don't think I need to prove this. You already know congruency, how to prove. Okay. I am just giving the order and postulate. Okay. Triangle AMN is congruent to. I have told you that there will be extensive use of congruency everywhere in geometry. Okay. So triangle AMN is congruent to triangle CPN. This is the correct order. By angle side. Angle is possible. See here in these two triangles, angle A is equal to angle C. Angle A is equal to angle C. Alternate angles because these two lines are parallel. Angle M means angle AMN, this one. Angle AMN is equal to angle P. Again alternate angles. We got two angles. Then AN is equal to CN. This is given from the beginning. This is given. Now here MN are midpoints. AN is equal to CN. So by angle side postulate, these two triangles are congruent in this order. AMN CPN. Okay. Next, we can write AM is equal to, see, AM means 1 2 is equal to CP. Okay, but AM is equal to BM given. AM is equal to BM given. Okay. So AM is equal to CP. Again AM is equal to BM. So we can say BM is equal to CP. Let it be equation 1. So we got BM is equal to CP. Okay. Now in quadrilateral BCPM, look at the quadrilateral BCPM. Look at the quadrilateral BCPM. BM is parallel to CP by construction. Okay. BM is parallel to CP by construction, and BM is equal to CP from equation 1. Okay. From equation 1. So you can see that in this quadrilateral BCPM, one pair of opposite sides means BM and CP are parallel and equal. So by theorem, which we have studied in rectilinear figures, the previous chapter, theorem number 1 of that chapter. By theorem number 1, if one pair of opposite sides of a quadrilateral are parallel and equal, then it must be parallelogram. Okay. So we can write here BC EM is GM parallelogram. Why? Because one pair of opposite sides are parallel and equal. Okay, so it is a parallelogram. Okay, now it is a parallelogram. So now we can say that MP parallel to BC. Okay, look at the figure. BCPM is a parallelogram. Okay, I am giving the sign, parallel sign. BCPM is a parallelogram. So opposite sides should be parallel. So I have written MP parallel to BC. Okay, opposite sides of parallelogram. If MP is parallel to BC, we can clearly say that MN is parallel to BC. Look at the figure. If MP is parallel to BC, then MN is also parallel to BC because MN is a part of BP. MN is a part of BP which is parallel to BC. Okay. So one part we have proved. We had two targets. First target was to prove that MN is parallel to BC. This part is over. Next target is to prove that MN is half of BC. Now we will prove that one. Okay. See, we had already proved congruency between triangle AMN and CPM. Okay, I can write that one. Triangle AMN is congruent to triangle. Actually, I don't need to write since I have erased. Therefore I am writing. Otherwise, I have not written. Okay, I have already written this once. So AMN is congruent to triangle CPM. This one is by angle side postulate. You might remember this, we had done this, okay, while starting the proof. So from this we can say Mn 2 3 is equal to Pn 2 3. So Mn is equal to Pn by CPCT. Mn is equal to Pn means this one. Mn is equal to Pn. Okay, by CPCT. If Mn is equal to Pn, then they must be Mn and Pn both must be half of MP. Okay, from the diagram see. If Mn is equal to Pn, both must be half of MP. Clear? Now, in place of MP, okay, look at the figure. In place of MP, we should be able to put BC because MP and BC are opposite sides of the parallelogram. Okay, and they are equal. Okay, opposite sides of parallelogram. So hence proved Mn is half of BC. Okay, so we proved this too. First is Mn is parallel to BC. Second is Mn is half of BC. So remember this theorem. The line segment joining the midpoints of two sides of a triangle is parallel to the third side and is half of it. Okay. If this is 5 cm, this will be 10 cm. Or if this is 20 cm, this will be 10 cm. If this is 40, then this is 20. And these two are parallel. Okay. This is MP theorem, midpoint theorem. Next is converse of MPT or converse of midpoint theorem. Converse of midpoint theorem. Okay. Theorem number 2. Converse of midpoint theorem. It states that the line drawn from the midpoint of one side of a triangle parallel to the second side bisects the third side. Okay, so let me take now write it. The line drawn from the midpoint of one side of a triangle parallel to the second side passes to the midpoint of the third side or bisects the third side. This is called converse of MPT. This is closely related to the previous theorem, that is MPT. MPT stated that midpoint then parallel. Okay, midpoint then parallel. And how? Converse of MPT states that midpoint parallel then midpoint. Okay, very simple to remember, very easy to remember. So let us draw a triangle. Let us draw a triangle. This is A, B, C. Let us take the midpoint of AB. Suppose this is P. Okay, P is the midpoint of AB. Now we will not take midpoint of AC like the previous theorem. What we will do, we will start a line from P and parallel to the BC, to the side BC. Okay, like this. Parallel. Let this point be Q. The point where this line, this parallel line to BC from P is intersecting AC is Q, suppose. We are going to prove that this point Q is the midpoint of AC. Okay, so let us start. Given AP is equal to BP, that means P is the midpoint of AP. Okay, more what is given? PQ is parallel to BC, as you can see in the diagram. To prove Q is the midpoint of AC, okay, or AP is equal to PQ. This we are going to prove. Let us go to proof. Again we need construction. Do the same. Draw CR parallel to BP to meet PQ produced at R. Okay, that means through C we are going to draw a line parallel to BP or BA, which will meet PQ produced at R. So let us produce PQ like this. Then through C let us draw a line parallel to BP, parallel to, so this is parallel. Okay, let this point be R. So look at the figure. BCRP, BC parallel to PR. Okay, this was given, and BP parallel to CR by construction. So we can say that it is a parallelogram. Okay, so we can write here BCRP is a parallelogram. Why? Because by definition, what is a parallelogram? It is a quadrilateral in which opposite sides are parallel. Okay, by definition, since opposite sides are parallel, so it is a parallelogram. Okay, so now we can say that BP is equal to CR. Okay, BP is equal to CR. BP is equal to CR. Why? Opposite sides of parallelogram. Opposite sides of. So again and again we are using rectilinear figures, the concepts of rectilinear figures in this chapter. Okay, so BP equals CR, that will be equation 1. in triangle APQ and triangle CQR. Look at these two triangles, this triangle and this triangle. Okay. Angle A is equal to angle QCR, alternate angles. Okay, this angle is equal to this angle, alternate angles. Okay, then we can say AP is equal to CR. How? Because AP is equal to BP. AP is equal to BP. This was given, and BP is equal to, you can say BP is equal to CR. BP is equal to CR from equation 1. So you can say AP is equal to CR. AP is equal to CR. Okay. Next, angle APQ is equal to angle this angle is equal to this angle. Alternate angles. Again alternate angles. Okay. Alternate angles. So by angle side angle postulate, okay, these two triangles are congruent. A, PQ, congruent to A corresponds to C, P corresponds to R. P middle means R middle, last option is Q. A as A. Okay, so these two triangles are congruent by A as a postulate. Okay. Next, now you can say AQ is equal to CQ. AQ is equal to CQ by CP. Okay, AQ is equal to CQ by CP. Hence proved. Okay. So this was our target. AQ is equal to CQ, or Q is the midpoint of AC. Hence proved. So remember this theorem. The line drawn from the midpoint of one side of a triangle parallel to the second side bisects the third side, or passes through the midpoint of the third side. Okay. This is theorem number 2. Then the last theorem. There are only 3 theorems in this chapter. Then we will move to examples. Okay. In the next part, I will move to examples. Last theorem is equal intercept theorem. Equal intercept theorem. What is this theorem? If a transversal, I will explain what is transversal. Okay. If a transversal makes equal intercepts with 3 or more parallel lines, okay, then every other transversal will make sorry, grammatical mistake. Okay, will make equal intercepts. I'll explain the meaning of equal intercept. Okay, will make equal intercepts with those parallel lines. Okay, so part by part we have to understand this theorem. three or more parallel lines. Okay, that means we need at least 3 parallel lines. So let us draw 3 parallel lines. We can draw 10, 12, 20, 30, 40, any number of parallel lines, but we need at least 3. Okay, so I am drawing 3. 1. So this is L1. 2, L2, 3, L3. We can draw more than 3 parallel lines, but I am drawing only 3. Okay, at least 3. Now, if a transversal means a line which intersects or disturbs other lines. Okay, these 3 lines are means parallel to each other. Okay, so they are not disturbing each other or they are not intersecting each other. Now we will draw a line which will intersect all the 3 parallel lines. Okay, suppose this is a line, its name is suppose M, small m. Lines are represented using small letters. This line M is intersecting all the 3 parallel lines, means it is a transversal. You studied in lower class, a line which intersects other lines is called a transversal. Okay, so M is a transversal for these 3 parallel lines. So let the points of intersection be A, B, C. Okay, now this is called intercept. Intercept means gap between the 2 points of intersection. A is one point of intersection with the line L1, B is the point of intersection with the line L2, C is the point of intersection with the line L3. So these are called intercepts. The gap between 2 points of intersection, that is called intercept. Okay, and according to the theorem, if a transversal means if this line M makes equal intercept, means it is given equal. Suppose AB is equal to BC. Suppose AB is equal to BC. Okay, with 3 or more parallel lines, then every other transversal, now randomly you can draw any other transversal. Suppose I am drawing like this. Okay, I have drawn another transversal M, means that is also intersecting L1, L2 and L3 at points suppose A, B, C, D, E and F. Then according to this theorem, since L1, L2, L3 are 3 parallel lines and there is a transversal M which is making equal intercept, means AB is equal to BC. Therefore, this new transversal means line N will also make equal intercept. That means DE will be equal to EF. Okay, I cannot say that DE is equal to AB. DE may be equal to AB, may not be equal to AB. Okay, don't think that DE is equal to AB or EF is equal to BC. No, I am just saying that DE will be equal to EF. Okay, so these two will be equal. Let us prove this. This is for 3 parallel lines. We can draw more than 3 parallel lines. Okay, so let us prove this. Given L1 parallel to L2 parallel to L3. Okay, I have taken only 3 parallel lines. Then AB is equal to BC. As you can see, AB is equal to BC. It is given that this transversal line M makes equal intercept with these 3 lines. AB is equal to BC. Okay, AB is equal to BC. To prove DE is equal to EF. DE is equal to EF. Now let us go to proof. We need construction here. Join AF. To intersect line L2. Okay, to intersect line L2 at suppose point O. So let us join AF. Join AF. Okay, now this line is intersecting the line L2 at some point. Let this point be O. Okay. Now you can see CAF is a triangle. Okay. In triangle CAF, look at the triangle CAF clearly. CAF is a triangle. B is the midpoint of AC. You can see, or AB equal to BC. AB equal to BC. This is given. You can see. We can write BO is parallel to CF. BO is parallel to CF. This is parallel to CF. Why? Because L2 is parallel to L3. L2 is parallel to L3. Okay. L2 is parallel to L3. BO is a part of L2. You can see in the diagram. CF is a part of L3. You can see in the diagram. Okay. So you can see in this triangle CAF, a line has been drawn from the midpoint of AC. B is the midpoint of AC. A line has been drawn from the midpoint of AC parallel to second side, means CF. Then by converse of MPT, we can say that this point O is the midpoint of AF. Okay, by converse of MPT. So we can say AO is equal to OF. AO is equal to OF by converse of midpoint theorem. A line drawn from the midpoint of one side of the triangle parallel to the second side bisects or passes through the midpoint of the third side. For that reason, O is the midpoint of A. Okay. Let it be equation 1. Now look at triangle AFD. In triangle AFD. In triangle AFD, look at the triangle AFD. We have already proved that AO is equal to OF. Okay. Look at the triangle AFD. Again, O is the midpoint of AF. Okay. We have already proved. AO is equal to OF from equation 1. Okay. So O is the midpoint of AF and OE. This OE is parallel to AD because L2 is parallel to L1. OE is parallel to AD. Why? Because L2 is parallel to L1. OE is a part of L2 and AD is a part of L1. From the diagram you can see. So again we can use converse of MPT. A line has been drawn from the midpoint of A, that is O, parallel to AD. So it will definitely pass through the midpoint of the third side, that is DF. Okay. For that reason we can say DE is equal to EF by converse of MPT. Hence proved. Okay. So remember this. If there are 3 or more parallel lines and there is a transversal which is making equal intercepts with those parallel lines, then by this theorem, by equal intercept theorem, every other transversal, not only 1 or 2, every other transversal will make equal intercept with those parallel lines. Okay, so these are the 3 theorems: midpoint theorem, converse of midpoint theorem, and last one is equal intercept theorem. Okay, so I hope you have understood this part 1. Thank you for watching.